3.12 equivalent representations of trig functions. Part 1. Here we go.
In this section, we will explore several ways to write equivalent representations of trigonometric expressions. We already have several tools in our math toolbox that we can use to write trigonometric expressions in different forms.
All right, fantastic. So when I talk about these, cosecant is really the reciprocal of who? Sine. Sometimes when we think of like cosecant in the denominator, it's really sine in the numerator, okay, because it's a reciprocal of that, okay? Same thing with cosine and secant. Secant is the reciprocal of who? Cosine, and then if secant's on the bottom, it's really cosine on top. And so tangent is the reciprocal of cotangent. However, what is tangent really? It's y over x on our unit circle. That's how we think about it. True that. But it's really what? Sine over cosine. And cotangent is really what? Cosine over sine. All right. Yes, those are reciprocals of one another, but we can go further. All right, keep going. You're doing great.
Okay. These identities allow us to manipulate trigonometric expressions and rewrite these expressions in equivalent forms using various trig functions.
All right. So we are basically going to manipulate the crap out of things. All right. That's really what we're doing. All right. And so really we're just manipulating and rewriting things and just changing the way things look. All right. It's not going to feel like you're going to do a whole lot. We're just changing answers, all right, and in equivalent forms, okay? So let's look at example 1. So we have these 3 trig functions going on, and I need to write it as an expression of tangent and no other function. So sine, can I change sine at all? Really, not too much. And so we're just going to call that sine x. However, what is secant squared x? What is secant x? It's the reciprocal of what? Cosine. And so this is really like 1 over what? Cosine squared x. And then what is cosecant? What is the reciprocal of sine? And so if I have cosecant in the denominator, that means what? I have the sine in the numerator. And so that's kind of how we're just rewriting and manipulating the way this looks. And so we're just multiplying across. So what's in my numerator now? Sine what? Sine squared x. All right, it's sine x quantity squared. And then it's over what? Cosine squared. And so what is sine over cosine? Tangent. And so what's sine squared over cosine squared? Tangent squared. All right, and so now we just have tangent squared. So what we noticed is this is equivalent to tangent squared. They are the same. They just look different. We just manipulated it. Here we go. So we have cosecant and tangent. Now we're going to write this involving just secant and no other trig function. And so right now, let's do it. So what's cosecant? 1 over sine. And then what's tangent? Sine over cosine. And so, what do we notice that will happen? The sine x's do what? They cancel. All right? Just like we do those little boxes in chemistry, remember? And you just go, all right? So my sine x is canceled. And so now I'm left with what? 1 over cosine x. And what really is 1 over cosine x? That's secant x. And there we go. All right, so let's look at this one. Miranda's going to keep going. She's doing great.
Additionally, we can discover several interesting properties and identities that arise from our understanding of the unit, circle, and trigonometric functions. First, let's start by relooking at the units.
All right, fantastic. So if I look at this little triangle thing, what kind of triangle do I have? A right triangle. All right, and so this is really what? And so if it's a unit circle, we have a hypotenuse of what? 1. And so this is our x value, this is our y value. Now, how did I want you to think of x?
As cosine.
Cosine. And then the y would be what?
Sine.
Sine. And so this is really cosine theta, and this is really sine theta. And what did you use to do right triangles? You used what?
X and y.
Pythag. You use Pythag. So it's like x squared plus y squared is equal to 1 squared. But really, this is like cosine of theta squared plus sine of theta squared is equal to 1. And that is right here. So that is where that comes from. All right, it's formed by that right triangle that we've been dealing with before. And that's called a Pythagorean identity. All right, a Pythagorean identity. So let's keep moving. And so our Pythagorean identity can be manipulated into other forms. All right, and I want to show you how we can get those other forms. All right, so the only thing that we need to remember is what? Sine squared plus cosine squared is equal to 1. All right, you have to remember that one. However, I'm going to derive the other two. And so because there's actually 3 of them, and so we need to get to the other 2. And the only way to do that, or the way to do that, is to divide by sine squared or cosine squared. So I'm going to divide everything by sine squared first. And so when I divide everything by sine squared, what's sine squared over sine squared? 1. And then plus, what is cosine squared over sine squared? Cotangent squared, exactly. And then is equal to 1 over sine squared, which is what? Cosecant squared. And so that's our other one of our true Pythagorean identities. All right. And so we're going to do it again to get to the third one. And so now if we have sine squared plus cosine squared is equal to 1, I'm going to divide everything by what this time? Cosine squared. So now I'm going to divide everything by cosine squared and see what we're working with now. And so sine squared over cosine squared is what? Tangent squared. All right. And then plus, what's cosine squared over cosine squared? 1. And then is equal to, what's 1 over cosine squared? Secant squared. And so now we have all 3. All right. And so the only one that we have to memorize is this sine squared plus cosine squared is equal to 1. And then how do I get these other 2? Divide by what? Sine squared and cosine squared. All right. So let's look at this one. So now we have tangent x over cosecant x, and we're going to rewrite it as a power of cosine. All right. And so just like before, what is tangent? Sine over cosine. So now I'm just going to have sine x over cosine x. And then what is cosecant? If I have cosecant in the denominator, that really means who's in the numerator? Sine. So now I'm going to have sine x in the numerator. Do you see how we manipulated that? We just converted everything to sines and cosines. So now in my numerator, what do we have? Sine squared x. Exactly. Sine x squared over that. So now, because this says, hey, I want everything in terms of cosine, we need to manipulate something. And so I have this sine squared that I need to get rid of. And I need something with cosine. And so, remember, we have sine squared plus cosine squared is equal to what? 1. And so how do I solve for sine squared? What do I need to do with this cosine squared thing? I need to move it over. And so what really is sine squared? I need to move this over. How would I move that over? I would subtract it. So sine squared x is really what? 1 minus cosine squared x. All right. And so then I'm just going to replace sine squared with what? 1 minus cosine squared. And so this is really just 1 minus cosine squared x over cosine x. And so now I went from tangent over cosecant, and that's the same thing as 1 minus cosine squared over cosine. All right? I just manipulated the way it looks.